Hello everybody. As Neil graciously introduced me, I'm Alexander Myers and I'm TransPower's Comptroller. We're based in San Diego County in a city called Poway. And I'm here to give you a little bit of insight as to how firms like TransPower can help transform Southern California into a leading green innovator and a hub of green manufacturing. TransPower's mission is to become a supplier of components for clean technologies ranging from transportation solutions to stationary energy storage. And basically we want to use heavy-duty electric vehicles and stationary energy storage systems to revolutionize the way that our society moves people and goods, as well as electricity through our society. These are pretty big goals, and the only way that we're comfortable attacking so many projects is by coming up with flexible building blocks that can apply to several different problems. So we have energy storage modules, power conversion solutions, and other technologies that we've designed to be modular so that we can attack as many issues that cause pollution in our society as possible. The first target area for TransPower technology is heavy-duty electric vehicles. Heavy-duty electric vehicles make a lot of sense because there's a wide range of heavy-duty vehicles that have short duty cycles. They don't travel very far during a day. They spend most of their time stopping and starting or idling, and they warehouse the vehicles in a central location. So charging isn't really a problem for these vehicles. And that ranges from port drayage trucks to garbage trucks, school buses, transit buses, a whole bunch of different vehicles that fit into this category. TransPower has focused on port vehicles as our starting point, and part of that is because the ports are so polluted that the people that live near the ports have a very strong need for relief from the air quality issues. And as a result of that, there are government funding agencies that are willing to fund research and development grants to develop these technologies. We also have fleet operators that are basically waiting for the zero emission solution because they see the marketing and public relations need to address this issue. And then also they recognize that there's an economic case to adopting electric transportation. We also have organizations like Portec LA that bring all these stakeholders together and provide a supportive environment for developing these technologies. So even though port trucks aren't the biggest market or the market segment with the most number of vehicles sold per year, it's definitely a good starting point for this type of technology. But we do have plans to expand to all sorts of heavy-duty vehicles that have the short duty cycles. The economics for an electric vehicle are basically the same whether it's a passenger car or a heavy truck. Basically, the vehicle costs more than its internal combustion engine equivalent, and at the same time has about 25% of the operating costs. So over the life of the vehicle, the operating cost reduction will pay for the capital cost that defines that vehicle. And we've calculated, depending on the assumptions that you use, between 4 and 7 years, that vehicle will pay for itself. And when you have a vehicle with a life of 10 to 12 years, any reduction beyond that is profit for the vehicle operator. So that's the basic market structure that defines heavy-duty electric vehicles, and that's why TransPower is moving forward with this technology. In order to make an electric vehicle, you have to replace all of the subsystems that are handled by the diesel engine. So rather than just move the vehicle, the diesel engine also powers the power steering pump and the electric air compressor, or it powers the air compressor for the brakes, the air conditioning. All of the other features are basically powered by that diesel engine. So in order to replace a diesel engine or a diesel system with an electric system, we have to solve an energy storage problem. We have to convert that energy into motion. We have to power the accessories, and then we have to come up with a control system that ties everything together. And TransPower has found that there really aren't any turnkey solutions or whole systems that you can buy to accomplish these functions. So we've been developing the subsystems up using our own technology. Our first prototype vehicle is the top vehicle up there. It's a Class 8 truck. It was completed in October of 2011, and it basically served as a lab test bench prototype to show that the components can handle the duty cycle and that we were on the right track. Then we took that knowledge and integrated the bottom vehicle, which is a yard tractor, and that's really our first fully functional prototype. We have additional vehicle models that are planned for 2013 that will take the same basic technology and expand it to a whole other range of vehicle uses. When I say port truck, it's the Class 8 truck that I'm talking about. And this is basically your standard big rig chassis. Obviously, an electric vehicle isn't going to go between the two coasts over the road, but the ports use these vehicles to move containers short distances. And that's been our most developed project because of the timing with the ports. This vehicle right here is one of the most powerful electric road vehicles in the world. It has two 150 kilowatt motors and can store up to 321 kilowatt hours of energy. Just to put things in perspective, my electricity bill last month was about 800 kilowatt hours. So every time this truck charges up, it uses about 35% of the electricity that I personally use in a whole month. At the same time, like I mentioned before, the operating cost reductions, we hope that demonstration projects, so actually when we get to put these vehicles into service, our estimate is that we'll see a $50,000 a year reduction in fuel costs. So even with that much electricity usage, it pales in comparison to the amount of diesel fuel that these big trucks use. And then the yard tractor is a similar platform. It moves the same containers around, but generally is limited to a warehouse or distribution center. And so since it only goes about 15-20 miles an hour at most, it only has a single 150 kilowatt motor and a little bit less energy on board. And we have two of these vehicles that are funded. They're going to be tested in Texas over the next couple months for a period of 6 to 8 months. We have a few other projects that we're proposing based off of this chassis. The other project that we have funded for 2013 is an electric school bus. It's funded by the California Air Resources Board. And this is really a good example of the modular approach to our technology. This is the same drivetrain this vehicle will have the same drivetrain that's in our yard tractors. The only difference is it'll have a few more gears so that it can get up to highway speeds. And we can get away with that because it's a much lighter vehicle. So it's basically the power requirements are a trade-off between how much load it can pull and how fast it goes. The difference between the school bus and the yard tractor is not as big of a difference as you might think given the different applications. Then on the stationary energy storage side, we have a funded project to develop a grid saver unit. And this is basically taking the batteries from an electric truck and some slightly modified inverters and putting them in a shipping container and parking them at a renewable energy site or a utility substation or an end user with a factory or large installation. And it can store between 1 and 100 megawatt hours. It really doesn't matter. It's a fully modular system. It can provide 5 to 100 megawatts. It's really just a matter of how many components we put in the system, but it's fully modular and can scale. There is a bottom end to how it can scale based on the technology that we're using, but there really is no upper end. And the plan is next year to build this device and then get it to a renewable installation for demonstration testing. Right now, it's still in the design stages. We have a very deep management team with our top 4 executives have over 100 years of experience between them in various management and engineering positions. And that's another reason why we're comfortable taking on a wide range of products. We have key personnel with a lot of experience in different parts of the ecosystem. The CEO of TransPower formerly founded ISE Corporation which was a leading manufacturer of hybrid buses, basically starting in the late 90s and into the early 2000s. And that TransPower is basically round 2 of that development effort, but with a focus on pure electric as opposed to hybrid. And one point I wanted to make is that I saw in the materials for this Green Salon, there was the phrase, a quick transition from idea to product. TransPower has been working on this idea for the last 2 years, and I would say we're about halfway through that process. And a lot of that has to do with the fact that these are really complicated systems with a lot of moving parts and a lot of components. But at the same time, when you flesh out the idea, that's almost the beginning of the journey rather than the end of the process. So that's why it's so important that we have the other organizations like incubators and government support for clean tech companies, because this really is a long process that we see the light at the end of the tunnel, but we're not there yet. We expect within the next 2 to 3 years to start commercial sales, and that extends from components to subsystems to the whole vehicle. One thing about this industry that's pretty interesting is that even though it's a competitive industry, competition isn't getting in the way of cooperation. As you said, it's growing so quickly that there really is plenty of room for lots of different approaches to address these issues. There are such big air quality problems, and there's so many trucks and so much pollution that it's not an issue to sell a subsystem to a competitor or to have someone else use a certain component. We don't view those as closely held secrets. The point is to get our products out into as many vehicles as possible so that we can maximize our impact as quickly as possible.
Thank you. Thank you.